more numerical ones.
Yeah, we'll just wait till they get them on more. No, yeah.
Okay.
Doesn't. Oh, hold on, sorry. Clicked on 3 again. Okay, so this one, the charting.
Okay. So notice that it goes down and to the right. So
Mm-hmm.
for these 25 students, this is part A, as the time spent watching TV increases, the time spent doing homework tends to decrease.
Tends to.
That will be the drop down. Okay.
Okay.
For these 25 students, there is negative correlation. Negative is when it goes down and to the right there, the drop down.
Mm, okay.
All right. So now go to the graph and go to the x-axis where it has 18. Yeah, right there. Go up until you hit the curve, the line, all the way up till you hit the line, and then go straight left,
Mm,
all the way to the y-axis. It looked to me about 14.
14. Yeah.
Yeah,
So 13.4.
13.55 looks good. All right.
Next one. Okay, so this one.
All right. If you click on the drop down there for the, I can't, I didn't see it. So
Oh, I'm sorry. Can you see it now?
no, that's odd.
It's
What did the
greater
drop
than
down?
or less than. I don't know why it's not showing.
That's okay. The percentage increase in sales that are greater than the mean value for percentage increase in sales tends to be paired with values for campaign that are blank, the mean values for the campaign cost. I guess greater than, um, not really sure. It's written a little,
It's a little weird.
all right. So, according to the regression equation, there, okay, so go up to do you see where it says y equals 6.15 plus 0.18x?
Mm-hmm.
Okay. According to the regression equation, that's the regression equation. For an increase of $1 million in advertising campaign costs, there is a blank increase in how many percent in sales? That's the slope. That's the 0.118.
So 0.18.
Yep. Now it says percent. I don't know if it's gonna, I don't know if it means eight, like that we change that to 18.
8.
So I really don't know. I think it's
Um,
0.18, I guess.
we'll try it.
I would go with that. All right.
And then let me see. Same one. We can skip it. Have more or less of a view of it. Okay, so these ones. So I'm gonna take the sample, and then it comes out with a bunch of these numbers.
Yeah, this one
I
is
I have a more or less like kind of I guess of you because I know like n is 9. I know that.
right, right. And X bar is the mean of the X's, Y bar is the mean of the Y's, S is the standard deviation of the X's, and so on. Scroll down there for the rest of that.
Mm-hmm.
There's the equation. All right. I mean, I'm happy to do this problem for you. But is this like how you, I mean, just asking, throwing out there, do you want us to, all I'm going to do is do it in Excel where it's going to
Be
automate some of these
easier.
calculations. Is that
Okay.
okay with you or not?
Yeah, that's totally fine. If you can you like share your screen when you do Excel, so maybe I can do it like that next
Yes, yes.
question because I don't mind
Yes.
working in Excel.
All right. Yeah. What I need to do here is if you could just scroll up so I could see the data set, uh, that would be best. That's perfect. All right. So, all right. Give me just a moment to enter the data. Oh, they are giving you XY. Oh, that's good. That's fine. All right. 31, 8, 14, 24, 19.
Yeah, I was doing
Right.
these ones kind of like by hand through the calculator, and oh my goodness, it took a
Yeah,
while.
it's bad to do. Yeah, by hand. That's for sure. 518. All right. Um, I do need to grab a couple of snips, so just hang on. I'll tell you when to move your screen down. Okay, you can scroll down, please. Um, Let me grab this. All right, I've got it. So let me go ahead and share my screen. All right, just gonna increase this. Okay, so first thing, XY here. There's a
Mhm.
couple ways to do it. You can just grab the cell A2 and multiply it by B2, hit enter, and then you can grab this little handle on the lower right and double click and it'll automate all of that for you. So in terms of like what you're trying to calculate, like you said, you already know that um, the n is 9, which I'll summarize here. So I'm going to insert a row here, and we're going to get some other things. We're going to get the average. We'll just type this out here. So you do equals the average, and then you just grab those data values right there. And then the nice thing is you can just drag it over to get those. Um, it says round decimal values to 3 decimal places. So in Excel, you can do that with the number thing right there. I will make sure to copy these into the notes here. Standard deviation is net. All right, equal. All right, let's grab those, then I can copy that over. So there's those values. That's why, the software is so useful because you can get those values. And then the sum, again, it's another built-in thing in Excel.
Mhm.
You can also get this from what's called a regression analysis. But uh, all right, so those are the first things. Now, to get the
Mhm.
slope and the intercept equals the slope. So I'm going to grab the y values, comma the x values, and it just calculates that for us. So that's minus 0.483x, and the intercept is the same thing. That's plus 18.265. All right, so let me just narrow those down. And I can send this over also if you want
Okay.
it for other problems. So let me go to the other screen here. So I've got these values down for n, x bar, y bar, sx, sy, sigma xy. And then here's the equation that goes in here for part B. Let me know if you need a moment to get that down.
Okay, just give me 1 second. Okay, so that's negative. So just to clarify that, it's like a negative 0.438x plus 18 point
It's
two.
0.483.
Oh, 0.483.
we're talking about this one here for the regression equation. Yeah,
0.486.
0.483. Yeah.
Making sure. Okay, we're good.
Yep. And then predict the amount of hot chocolate sold a day when the high temperature is 16 degrees. So we're going to put 16 in for X.
16.
All right. So you got to just put this into your calculator or
Yeah.
software. And
So I got 10.537.
that sounds right. Let me just double check here. I got, oh, because I'm using the rounded values. Yeah. Yes. That sounds right. Nearest whole number. So to round to, I guess, 11. All right. I think that's everything for that problem. Go ahead and share your screen whenever you're ready, and we'll keep working at it.
Yes, 1 second. For that line, we're just putting it where? Because that's what they're just telling me.
I mean, I don't know.
Okay. Let me.
Uh,
11.
I'm not really sure. I mean, it's I've never seen this in Alex, so
Okay.
drawing the line through. So it wants you to plot 2 points. So you got to put like x equals, I don't know, 3. To put like 3 in for x, 3 comma whatever you get when you put 3 in for x, and then make another point maybe for like 18. So you're gonna use that point tool first, but you have to put these x values into the equation and then get the output.
Okay. 1 second. So like for the equation for like -3, I'm a little confused. I'm sorry.
You're putting 3 in for x just like you did below here. Let me try. You're putting this in for x and then 18 in for x, and you'll get 2 y values.
Okay. Three.
Those are the ordered pairs you'll want to graph.
Let's hope. If not, it's okay. I'll just ask my teacher about that second part. B.
Maybe recommend moving on, accepting the partial credit on this.
Yeah, I will. Let's go to the next one.
All right, so go ahead and share your screen whenever you're ready. There we go. Okay. Yeah, this one's a bit more involved. Let me grab a snip of this. Okay. All right, so let me share my screen. All right, so the this is a hypothesis test on slope B1. So your null hypothesis is that beta 1 equals 0, and your alternative is that beta 1 does not equal 0. This uses a t-test.
It asks us when we put the t-test, it asks us for a degree of freedom.
All right. So it's based on the sample size is going to be the degrees of freedom is typically n minus 1, 16 minus 1 in this case, 15.
Okay. And then
Is that okay?
yeah.
All right. So the simplified formula for the test statistic is it's the slope, which is 0.041 of the regression equation. It's the slope over the standard error, which is 0.029.
So 1.414 is what I got.
Yeah, what does it say? Three or more three more decimal places. Yeah, 0.041. Yeah, so whatever you want to go with, 1.414 would be good. And then the p-value, because it's a two-tailed test, you're finding the area in this tail on the right and then doubling it because it's got to be paired with this area on the left. So to do that, you really need software or some sort of a tool. Um, for this, I don't know what to suggest. But the area ends up being p-value ends up being um, 0.178. All right.
So it's better to use like Excel when we're like answering these questions, is what you're saying?
I use different pieces of software. It depends on what you like using. Excel is probably the most user friendly
Oh,
for this. Or just going out and looking for a key calculator,
okay.
like Stat Trek is pretty good.
Okay. Stop track. Okay. Definitely I'm going to look into that.
Sorry. So the last one here is a no. It's because the p-value is greater than alpha.
Yeah. Sorry, that's what I put no too, but I just wasn't sure.
Yeah,
It's
yeah.
saying that the degree freedom is wrong for B.
Might be 16 minus 2, which is 14. Um, and then that will affect the p-value a little bit. It'll be 0.179.
Zero, well, yeah, that's okay. 0.179. It's being picky like of how I entered A for some reason. So
So,
B1.
so you have to use underscores. So they're
Oh,
under the mu, they're on the right, um, down below, down below the mu. Nope, to the right.
yeah.
You're yeah, just go to where that U is and go to the one below it. That's the
Ah,
underscore subscript.
okay, there we go. So the next one. Okay, so this one.
Uh, there's a formula for confidence intervals. Could you click on that formula, list of formulas there, see if I can find it? Yeah, could you scroll down? Looking for the one for confidence interval. There it is.
This
Wow.
one?
Yeah. I'm gonna suggest we skip that, but leave that up to you. Let me grab a snip of it real quick.
Oh, sorry. Go back to three.
I got it. I grabbed it. Yeah, so like let me see here. Do we have all those information? So we have the X, we have B0, we have B1. Okay. Do we have the T? We can calculate the T. Do we have the square root of D, where D is 1 over N? See, I just, oh, they do give you that. Okay. I guess we've got enough to do it. All right. Yeah, we can do this.
Okay.
Was it degrees of freedom N minus 2 in that previous one? I think it was,
It,
but
yes, it was. It was
okay.
N minus two.
All
It
right.
was
Could you
14.
scroll down for part B? All right. Let's see. Okay. Let me share my screen. All right. So the formula here we're using for this is keep in mind that they're giving you this number. It's this right here. I think it's 0.07.
Okay.
And this one right here, 0.07. So we've kind of got it. So B0 is the 3.02 plus 0.16. Now this X0 here is giving us 31.4. Okay, so that's the first part of this. That's this calculation here. Plus or minus, okay. So the um the next thing we need is this T alpha over 2. So there's 15 comedies. That means the degrees of freedom is 13. Your C is 95%. Somewhere it said it wanted 95% confidence interval. So I'm going to look that number up for us. Uh, that is 2.160. So it's 2.160. The mean square error is the standard deviation. That's 15.32. And then times the square root of that 0.0 times the square root of that 0.07 number. So it's all there. I don't know how easy that is to see, but that is everything. I'll do the calculations here. Hopefully it worked out. Plus 2.160 times 15, 32 times the square root of 0.07. All right, so the confidence interval I got, which really hoping here for at least around your answer to at least one decimal place. All right, minus 0.7 is the lower limit. 16.8 is the upper limit. Um, all right. So then to answer this next question, it's asking you to compare these two formulas. And the only difference is this over here on the right.
Plus one.
Basically, it's got the same center. The first part is the center. This will just make it a little bit wider. So the same center will be a little bit wider, I think. Yeah. The interval computed. So this is part C. Um, they're saying that 78.6 is actually more extreme than 31.4. All right. How would the 95% confidence interval when the theta revenue is 31 compared to 9 for the 78.6? Um, so they're asking like how does this number affect the value? This number is right here. So it only affects the center of it. So it's the one that says that has the same center.
So big,
Um,
wider, or what is it
it
like
would be
narrower or wider?
wider. Yeah, I'm trying to look at that. Why would that change? Um, I think it would be wider, I guess, if you're asking me, based on what I know. So we'll go with that.
Um, I don't know. A tough question. So maybe I don't know. Maybe I just might go back and ask her to explain this one a little better. This
I
question.
I don't know.
Yeah,
Because
I think I'm
these are
gonna ask her
yeah,
to explain this one a little better.
okay.
But I mean, let me try.
Yeah.
Let me see the next one. Okay, can you help me with
All right.
this one?
Yeah, this one's fine. So if you look at the estimated model, you can see now there's three variables.
Yes.
There's one for X1, X2, X3. X1 is the total floor area, two is the number of bedrooms, three is the distance to the nearest high school. Um, for each additional bedroom, that's X2, that's the slope in front of X2, which is $19, but it's in thousands. So you have to remember to multiply by 1,000. So the answer is 19,000. It's the slope in front of X2.
Uh-huh. See, that's. I mean, I was kind of understanding that, but then I was getting thrown out. So just remembered like the thousands or yeah, square feet in miles. I see. Is this a change? Is it change?
And it's because it's positive, it's an increase.
There was another one. It
That
wasn't.
the one you just went through, we
It
could
was
do, or this one, those are also easy to do.
okay.
If you want to scroll down a little bit. Yeah, keep scrolling down. We can grab all this. All right. Okay. You scroll all the way down. Yeah, let me get all of it away. One step. All right. All right. So for this problem, um, the way you calculate the expected frequency is you first uh, take the total and divide it by the number of like entries, which is 5. So they're actually all 22 in this here. All right, so I'm gonna call this A for the moment. So A is 25, that's the observed, minus the expected 22 squared over the expected 22. So that's it's I moved decimal places, but I think 3.409. For B, you take the observed, which is 18, subtract the expected, which is 22, square it over 22. Which is 0.727. Okay. Now the type of test statistic is a chi-squared there, not a chi. It's a chi. That is the correct
Yeah.
pronunciation.
For that one too, it asks us for a degree of freedom. So is that
Degrees of
one?
freedom in this case is the number of columns minus one, so 5 minus 1, which is 4. The value of the test statistic is the sum of this row down here. Like that. So I got 12.090, but please double check that.
Yes.
All right, so the way you do the p-value is you got to again use software. The chi-squared is this shape here. You find this, and then you want like what's in the right tail. Um, so again, probably some sort of calculator will help you. It ends up being 0.017. Okay, so that p-value is less. Actually, I have no idea. Do you know if it was 0.05 in the
Um,
confidence level? There it is, right there. There it is. Okay.
oh, yeah,
So since
zero.
the p-value is less than that, you can say yes for that one. All right. Go ahead and grab another question, see what we can work through. That next one looked okay too. It's with the table. That's
I'm sorry, I'm just still typing in again. I'm sorry.
okay.
Right, so next one.
All right. This one here, grab the table. All right, let me share my screen. Okay, so to find, whoa, why are there, maybe I misunderstood what. Could you go back and share your screen? I don't know what it wants us to calculate. And the cells of the color are the observed frequencies, the blank frequency expected. Okay. All right, thank goodness. It's weird that they're doing it in the same table. All right. So to find for A, you take the row total, 206, times the column total, 693, then you divide it by the super total, which is 2000. And it is a rounded result, so it's 71.379. To find B, you take the row total. So notice you're in the second row, 1794 times the column total, 693 over 2000. And then for C, kind of the same thing here. You take the row total, 206, times the column total, 707 over 2000. Which is 72.821. Boy, yeah, so this one's pretty involved here. Let me, I guess, do this in Excel. I don't know. Let's see what else you got, because this is, I mean, are these all worth the same point totals?
Yeah, I mean, we could work on something different. I might have her explain that one a little more better. I guess a better breakdown of it. We can work on this one.
Okay. Uh, yeah, we can do this one, I think.
Okay.
But
If not, then I can go on to the next question.
the variance of the sample means. I actually don't know how they want you to calculate part A.
Okay.
Part B is a standard formula, so you might be better off getting the
Let's see.
tip from the instructor. What's the next one?
Same thing, and then so I'll have her explain that one, and then the
Oh,
next
these are
one.
ANOVAs. Okay. All right, so we can do this one.
Okay.
Let's scroll down just a little bit so I can get all of that. Yeah, that's perfect. All right. Let me share my screen. Okay. So the way to calculate this F right here, call that A. A is the mean square uh, between groups, so 0.62 divided by the 0.24. So you got to divide that.
I got 2.58.
All right, very good. 2.58, that works for me. How many listeners were tested in this experiment? So the the formula for some of these is like, it's like N plus K plus one. I believe there were 60. It's typically one more than that last one.
The degree of freedom. That's the one I would go off of.
Yeah. Um, for the ANOVA test, assume that the population variances of some values for this tone are equal for each population of listeners represented. What is the unbiased estimate of this common population variance? Um, we'll go with 16.23. And then using the 0.01 level, what is the critical value of the F statistic? So this is using software again.
Okay.
Uh, the degrees of freedom is 5. There's 2 degrees of freedom in this. So it ends up being 3.38 when you look that up. And then you're trying to decide, is your number bigger than that? So again, that F distribution looks like this. So it's like you're at 2.58, but the critical is there, 3.38. So this is a no, you don't reject.
It's saying 3 is wrong. C is wrong.
All right. I'm not sure. Could be 3.09, could be the 13.14. I'm not sure.
One of those. That's good enough. Okay. I believe that's all. The rest I'm gonna ask like my teacher about the rest. That
We got some time left here if you want. I mean, happy to, you know,
we
help a
could do
little
this
bit more.
one, the 3-1.
Sure, sure.
This one.
All right, so researcher measures shoe size and reading ability of a large group. She found that as shoe size increases, so does reading ability. What does her analysis show? Um, so there is a correlation between them, but there may or may not be causation. So that's letter B. The idea is that you can find correlation between a lot of variables, but does like shoe size actually impact reading ability? And the answer is no, that's ridiculous.
Yeah.
Um, uh,
No, that is ridiculous.
okay, a grocery store conducted a survey. It showed that when customers buy less cereal, it does not indicate a change in the amount of milk they purchase. Okay. Um, so there is no correlation because there's no change in milk. For there to be correlation, you have to have something increase or decrease.
I see.
Yoko compared the player statistics from the team's basketball season. She determined that being taller does not imply that a player scores more or fewer points. What is likely true? Um, that also appears to be no correlation, but I'm just surprised that um,
Okay. Just surprised what?
one of these is wrong. I mean,
Oh, I see.
it showed that when customers buy less cereal, it does not indicate a change in the amount of milk they buy. So they're
But I'm looking at C. Would C work for C? Because in this, however,
I
there's
mean, you would think that there'd be correlation in height and number of points scored, but there may not be. But they're saying no. They're saying that being taller does not imply that a player scores more or fewer points. I mean, you get 2 attempts on these. You get
yeah.
limited attempts, yeah. So I would try this, and if it doesn't work, we'll just
Okay, we'll see.
see what it says here.
It's correct. Cool.
Yeah, see,
All
sometimes you
right.
overthink these things.
Sometimes, definitely. But I appreciate it. I think we should stop now. I mean, the
Okay,
rest I can just ask my teachers about like 7.
sure.